Alrighty. Well, hopefully the first day went okay for everybody. And we're going to continue on. And I'll try to talk you through this answer key as well as I can. So if you watched the initial video that I posted on specific heat, it talked to you through the first problem. So let's keep the ball rolling and see how this works. And let's be careful. We'll do number 2 last. All right? So if this is our equation that we've been working with, Q equals Cp times M times delta T, I think that the easiest version to use is this version, Cp equals Q over M times delta T. But we don't always get that option. So for this particular case, what we're going to do is set this equation up to find mass. And what we're going to do, since we want to keep M by itself, is we'll divide both sides by Cp and delta T. So that gives us M is equal to Q over Cp times delta T. So this problem is asking for the mass of liquid water at room temperature, 25 degrees Celsius. Remember that temperatures doesn't need to be in kelvins, it can be in Celsius. It's the delta T that we're looking for. So what mass of liquid water at room temperature, 25 degrees Celsius, can be raised to its boiling point with the addition of 24 kilojoules of energy? Two things to be careful for. Boiling point of water, 100 degrees Celsius. And let's also remember that energy is in joules. So this 24 kilojoules of energy, we're going to want to get that into joules. Easy enough, we're just going to multiply by 1,000. So here we go. We want M. We have a Q, 24 kilojoules. We're going to put that into joules. The specific heat of water, pretty straightforward, except one of you asked me, Mr. O, how do we know which specific heat for water do we use? There's 3 of them. 1, 2, 3. Well, we want water as a liquid. So if you caught that, great. If you didn't, make sure that you're paying attention to that one. So we want specific heat of water, 4.18 joules per gram degrees Celsius. We have a delta T. We started at 25 degrees Celsius and we're going to 100. So our delta T is 75 degrees Celsius. Okay, bust out your calculator. 24,000 divided by the quantity 4.18 times 75. And I get 76.55 grams. Is our mass. Okay. Let's try number 4. It says a 10.14 gram sample of an unknown metal is heated from 25 to 250, and it was found to have absorbed 1,024 joules of energy as heat. It is asking for the specific heat and what is the unknown metal's identity and how much energy will the metal sample gain when it is heated from 250 to 750. So let's take this first part. First part is asking what is the specific heat of the unknown metal, and if we know that, we can easily find its identity. So specific heat, Cp. Going to arrange this equation to find specific heat. It's going to be mass times delta T. Okay, it says that we have a energy of 1,024 joules. We have a mass of 10.14 grams. And our temperature change is going from 25 to 250 degrees Celsius. So that's going to be a delta T of 225 degrees Celsius. So make sure you have your calculator handy. And we're going to say 1024 divided by the quantity, 10.14 times 225. And we get 0.4488. Let's round that to 0.449. And notice that none of these units cancel. There's nowhere for them to go. That gives us a value, or excuse me, our units of joules per gram degree Celsius. That's exactly what we want. All we have to do now is find a metal in our table that has a specific heat of 0.449, and right there, good old iron. All right, so we know the identity. We know that this is iron. Let's do the last part. It says, how much energy will the metal sample gain when it is heated from 250 degrees Celsius to 750? So let's put this equation back into our version 4, calculating Q, that's joules. Let's equal to Cp times M times delta T. Well, you just found the specific heat, 0.449 joules per gram degree Celsius. The mass hasn't changed. It was 10.14 grams before. It's still 10.14 grams. And our delta T, well, we're going from 250 to 750. It's a delta T of 500 degrees Celsius. So let's crank this out. We know that when we do this, grams is going to cancel grams, degrees Celsius cancels degrees Celsius. It leaves our answer in joules, which is exactly what we want. So we're going to say 0.449 times 10.14 times 500. Our answer is 2,275.5555555. Let's call that 0.6 joules. All right. Okay, let's go back up and we'll do number 2. And it's asking for the final temperature of the water. So we want to be careful. We have an initial temperature of 10 degrees Celsius. And to find the final temperature, that means we're going to need to find the delta T first. So let's rearrange this equation. If Q is equal to Cp times M times delta T, then delta T is going to be equal to Q divided by Cp times M. Okay, now it doesn't state that the water is in a particular phase. It doesn't say liquid or gas, but it's at 10 degrees Celsius, ladies and gentlemen. Water's melting point is 0 and its boiling point is 100 degrees, which tells us that our state of water is going to be the liquid state. And that means we're going to have this 4.18 joules per gram degree Celsius as our specific heat. So it says 420 joules. No, nice. We also have a specific heat, 4.18 joules per gram degree Celsius. And the mass, 35 grams, getting that right here. Okay? So let's bust out your calculator. Now all this is going to do is give us the delta T. So we're going to say 420 divided by the quantity, 4.18 times 35 grams. And we get a delta T of 2.87. degrees Celsius. All right. Be careful. Mr. O face. Telling you to be careful. Be. Try in, ladies and gentlemen. Be careful. Why? Because this is the delta T. We want the final T. So we're simply going to add that delta T to our original temperature, right? 10 degrees Celsius. And if our original was 10 and our delta T 2.87, that means that final temperature is 12.87 degrees Celsius. Okay, that's all 4. Well, 3 because you did the first one. All right, I'll see you on the next session.